All right, brought to you back by popular demand, Kunstman's lessons on classifying numbers. All right, so here we go. All right, first things we want to do is remember we talked about NWIR, and we said that was an important thing to remember, NWIR, because if we can remember that, then we'll be able to go down this list of what each of them are and easily classify what numbers belong to. Okay, well, let's review again what we said each of those were. Okay, natural and counting numbers. Those are the numbers that you normally just count with, okay? Numbers such as 1, 2, 3, and so on. Okay, so natural counting, whatever you just normally start counting with. Whole, well, that's just like your natural and counting numbers, but just like if you were to make a whole, you start off with that number. So your first number with whole is your 0, and then it goes on to your counting. 1, 2, 3, and blah, blah, blah. Notice it doesn't have any negatives in whole. It starts at 0 and goes from there. Also, no decimals or fractions when reduced. So, example on that one is if I were to say 5 halves. That can't reduce into anything that works. That reduces to 2.5. Okay, that's not a big number. But if I were to put up a fraction like this, say I use the fraction 4 halves, if I were to reduce that, that would reduce to 2 over 1 or 2. Now that does fall under the whole numbers. Okay, so I always want to simplify things whenever you have a fraction. Always, always, always simplify your fractions. Okay? All right, that brings us down to the next one, which is your integers. Remember integers? I said think about that number line. Okay, so I always go ahead, draw your number line. Your number line has 0, then it goes to the left, it has negatives. Okay, and then it goes to the right, and it has your positives. Okay, again, it's all the numbers. It doesn't include any of the decimals or fractions in between. And again, if it can reduce, like negative 4 over 2 reduces to negative 2, those fractions count, okay? So it's always when you simplify, if it then turns out to be a number, positive, negative, or 0, okay? All right, let's get rid of what I just... Whoop. I guess we'll get rid of it at the end. Okay, rational. Rational means anything I can either write as a decimal, like 0.628. Notice how that ends there at the end. It stops right there. Okay, another decimal I can do is just simply 0.5. It can be negative 1.8. It can be anything that stops. So it can either stop or it can be one that repeats. Okay? Repeating ones are fine. The ones we don't like are the ugly ones, like 0.18234, blah, blah, blah. Goes on. Those are ugly ones. Ugly decimals don't qualify as rational. Ugly decimals, like this right here, those don't fall into any of our categories over here, and those are your irrational numbers, okay? So, rational ones, those are numbers that I can write as a decimal, or I can write as a fraction. Anything I can write as a fraction is rational, okay? No matter how crazy it looks. Okay? So that's natural counting, whole, integers, and rational. Okay, so let's go through some of these. All right, let's see if I can't clean up what I've done here. Okay, clean up, everybody, everywhere. Okay, so here we go. Natural counting. So let's give an example here. Okay, number 1, let's do negative 4. Okay, so negative 4. When I'm looking at it, do I naturally count to negative 4? So do I naturally count to it? Negative 4? No, I don't naturally count to negative 4. So it's not natural. It's not going to be natural. Whole. Is it my 0? 1, 2, 3. No, again, it's bigger than that. That's negative, so negatives are not whole. Integers, well, I find it on that number line. Is it my negatives, my 0, or my positives? This case, yes, it is. -4 would be on that number line, so I know then that it's automatically an integer and a rational. So whenever I find out that it's 1, it's automatically everything below it too. So this one I would say would be an integer and rational. Okay, let's get rid of that one if I can. I may not be able to. Okay, forget about it. 2, 1/2. Okay, so 1/2. When I'm naturally counting, do I count to 1/2? No, that would be silly. So it's not going to be natural counting. Whole. Okay, well the only difference now is it 0 or do I naturally count to it? Nope, it's not 0. Is it an integer? Would I see it on a number line? Would I see it on this number line, 1/2? No, fractions don't fall on the number line. So it's not going to be an integer. Then I ask, can I write it as a decimal or a fraction? And in this case, yes, it is a fraction. So 1/2, the only thing we can categorize it as rational. Okay, let's try another one. Okay, let's do 100. Okay, big number. Okay, so let's look at it. 100. Can I count to 100? Well, the answer to this one is yes, I can. I can count to 100. So that means it's automatically a natural counting, and it's automatically everything below it. So it's natural, it's whole, it's integer, and rational. That's why it's important to know this order, NWIR. If you can remember that NWIR, and anytime you're doing classifying numbers, you should be able to do this pretty simply. So this one I would go ahead and categorize it as N, W, I, and R. All right, let's try another one. Okay, number 4. Okay, let's do the one I always like, pi. Okay, pi is one of those weird, wacky numbers. You put that into your calculator, or you look at the number, and it's one of those decimals that goes on and on and on and on and on. Okay, blah, blah, blah. It never repeats. So, with that being the case, let's go through. Do I naturally count to 3.1415, blah, blah, blah? No. Is it whole? Is it 0 or my numbers that I count with? No. Would I find it on the number line? No. Is it a decimal that either has a repeating bar above it, like 3.1 with the repeating bar, or is it a decimal just by itself that ends, or is it a fraction, 3/14? It's neither of those. It's none of those, because this is an ugly decimal. Ugly decimals go on and on. Ugly decimals, we say ugly decimals that don't repeat. Those ugly decimals are irrational. Okay, ugly decimals are irrational. So that is what pi is. Pi is an irrational number. So it doesn't fall under any N, W, I, or R. So when it doesn't fall into any of those categories, it's automatically irrational. Let's free up some space here. Oops. Okay. Let's see here. Okay, let's put back in my natural counting since I erased that. Okay, let's try another one here. Let's do, I don't know what number I'm on. Maybe I'm on number 6. Okay, so number 6, let's have you do, let's do -7. -7. Just go ahead and try that one out. Okay. So hopefully you've had enough time to look through or push pause and look at it. So once you've looked at this one, you'll notice that when I'm counting, I don't start counting negatives. I don't say -7, -6. So I start counting with 1. So negatives don't fall under my natural counting. Likewise, whole numbers, I didn't say, whole numbers include 0 and then my positives. So I don't start counting with -7 in whole numbers either. Integers, there's my number line. So would -7 fall on my number line if I went far enough back? It definitely would. So -7 would fall under my integers and then automatically everything below. So it'd be integers and rational. Okay, let's put up another one for you. Okay, what about 2/4? Okay, go ahead and push pause and try this one out. All right, hopefully with this one, you've gone ahead and looked and you've said, hey, I need to simplify 2/4. I see that 2 goes into both of these numbers. Okay, 2 goes into 2 once and 2 goes into 4 twice. So that reduces to 1/2. So with 1/2, then I'm going to go ahead and look over here and say, do I naturally count to 1/2? No, that'd be kind of silly if you did. I naturally start counting with 1, 2, 3. So that's not natural counting. Then, is it 0 or my counting? No, it's not 0, so it's not a whole. Integers, would I find 1/2 on the number line? No, I don't find fractions or decimals on the number line, so it's not an integer. Rational, okay, so is it a decimal or a fraction? And yes, this one is a fraction, so this one would fall under rational numbers. So that would only be a rational number. All right, let's do one more for you. All right, so 125 over 25. Okay, go ahead and push pause and try that one out. Okay, hopefully when you saw the fraction, you said, fraction, I need to see if it simplifies. Okay, whenever we work with 25s, that's just like, I like to think of quarters. So I have how many quarters in $1.25? Well, 5 quarters makes up $1.25, so 125 will reduce to 5. How many quarters make up 25? Well, that's just 1. So this fraction was pretty simple to reduce. It came down to 5 over 1, and that reduces to 5. Okay, so now let's go through our numbers here, and let's see our classification system and see what it fits. So 5, can I naturally count to 5? Yes. That's awesome. So now I know that it's automatically everything below it. Easy as can be. So that one would be all of them. That would be your natural, your whole, your integers, and your rational. All right, that's the end for today's lesson. I hope the review helped out. Shoot me any questions if you have any. Find me on Edmodo. All right, see you guys later. Happy studying.